Sir, let's go into Q&A session. Let me jump right into James, who has his hand up. James, I think you're in Europe, right? Because it's dark there. Oh, let me here. I'll do ask to unmute. Okay. Oh, James, you're still muted, sir. There we go.
Can you
yeah.
hear me? Yeah. Is it sort of similar? Was it Arthur Townsend?
Say that again, please.
Sort of thing. Was it Arthur Townsend? I might have got the name wrong.
No, this is David Perez.
No,
I know.
Yeah,
I know your name.
Oh.
No, my advice, right? Developing some technology like this is to keep as quiet as possible about it. Don't mention it to governments, or you'll find the Air Force come and close your lab down and take all your technology away.
Well, I mean, we've already been broken into, and one of our engines were taken, fractals were removed. They were pretty slick in what they did. I even had security cameras in, but the bottom line is I found that the best place to hide is in the public, clear view. You know, if somebody wants to do something evil to us, well, if they do, I can't stop it from happening. And I'm not wishing for any of that to occur. I want to continue with our research because this changes the way we move on the Earth and in space. It's too important to BS with politics and do all this militarization stuff. The future is space. Maybe I'm too idealistic, but we really need to concentrate to develop that new blossoming economy. And then everybody would be on an equal basis. In other words, you know, you can make as much money as you want. Everybody would have good standards of living. I'm trying to look for the future on this. The squabbling that we have here on the Earth.
I'm all with you there. Something I thought of, does this, because I'm an artist, so I'm not technically, no math skills, no engineering skills or anything like that. But I sort of get ideas pop in my head, and I've always been interested in things like this. And I just had this idea that space, it was just something come in my head that space-time has a small positive charge. I don't know whether that would pan out with what you're discovering.
Actually, I've been doing research on the entangled particles and the media space between the entanglement of the particles. And after doing, well, I was in the hospital for months. I had a lot of time on my hands. And and what I figured out and kind of realized after just, well, years of dealing with entangled particles and doing research on that, I had envisioned creating an entangled particle tunnel and pushing a warp bubble in it. However, all that has gone in the garbage. And what have found out is that the upper limit, like Harold Puthoff and some others have speculated that faster than light, you could only do 100 times, 1,000 times. Well, what I've come to the conclusion is it's the point of singularity. That's 26.1 million billion watts of power is your upper limit of faster than light.
Wow.
Using the concepts of, of a warp bubble. I think those craft that you see that they've been documenting with the video tapes from the aircraft from the F-18 Hornets, they're all using warped technology, using warp space. And the fact that they disappear is that you just have a lot more power and you're here 1 second and you're gone in the next, but you're already, I don't know, thousands of miles away.
No G-forces.
Well, there is no G. See, this is the beauty of the whole thing. There is no momentum inside. The crew is protected.
Yeah.
And this, at least we were able to glean from Bruce Gernon's flight, not just the 10,000 in and out, and the lack of tidal action around the bubble, the non-sustainable local spacewalk bubble, but the fact that he felt this sluggishness going into this thing, and then no G-forces on this aircraft.
Yeah.
He went, well, if you don't want to believe 360,000 miles an hour, thousands of miles an hour in order to traverse 100 miles. But he was lost on radar from Bimini Island and reappeared over Miami Beach. And approach radar rotates every 15 seconds.
Yeah.
So if you want to argue that he disappeared for 15 seconds on radar and reappeared on Miami Beach, then make the calculation and you'll find out it's in the thousands of miles an hour.
Yeah.
But I don't think that's how this works. We're talking 10 to the 15 watts of power on crossing these fields. And this particular individual, well, and others, as I described in the beginning of this, they went for the gusto, nature's brute force method. And that was my big significant problem. How the hell do I replicate something like that? To move an aircraft to displace it, linear displacement, hundreds of miles downrange. Do I fly it through two antennas? That was one of my ideas. Get two huge radio towers, energize it, fly the plane through it, and end up where you end up. That doesn't work. It's not practical. But the engines, fortunately for us, worked. And
it's amazing what you're doing. Great. I think, have you experimented with high voltage, or are you doing that?
It's RF generated. So we're actually transmitting frequency. It's propagation of electrons.
All right.
So our high voltage would be what type of RF current can we come out of the linears? And that's why radio stations can produce 100,000 watts of power.
Yeah, right.
But this stuff is too heavy, and I can't demonstrate in a lifter. We have that's why we have spent, and some people criticize us for trying to make it more efficient, smaller, more output, less power in, more output of work, energy, pulling power in our case. And but we've succeeded in that. I mean, in less than a year, we've doubled the amount of output and 100 watts less of input. So we more than doubled the weight of what we can lift and 100 watts less output. 1,500 watts, 15 newtons. I mean, that's why when we submitted this proposal, we went for 10. And an intermediate would be 6 for us, but I think we can get to achieve that level pretty easily at 6. 10, I'm a little dubious. I know we can do it, because you got to set up these milestones and timeframes and stuff. Doing it full time with the proper funding, I believe that we can get to 10 pounds easy in a year.
Cool, it's great, incredible.
Wonderful, wonderful. Okay, well, yeah, and let me move along. Thank you, sir, as well. Let me go to Bill Alec next. Bill?
Yeah, hi, Tim. Hello, David. Brilliant work, by the way. Great work. Just one thing. Now, the way that I understand it is that you're mixing two RF waves at an angle, right?
Perpendicular to the array. Yes.
Okay. Now,
and they're crossing over at that point.
Okay. Yeah, two RF signals in phase.
Yes.
Yeah. Okay. Yeah, I'm doing similar work, but at a much lower frequency. And I'm replicating Tom Bearden's work in this area. And he produced what's called a scalar wave. and you have to use quaternion mathematics, okay, in order to calculate this. And when you mix these two waves together, it creates a sine squared term. And what's really interesting about the sine squared term is that it has a DC offset with it. It's a higher frequency sine wave, sine squared wave.
Right. Okay.
But it has this DC offset to it. And Tom called that a scalar wave or a gravity wave.
Okay.
He used the two terms.
Yeah.
And I'm kind of wondering if, well, we could be talking about the same thing.
I think we are.
Your technology is producing a scalar wave, which is a real gravity wave.
Correct.
And that's the way that the mathematics works out. You can't use conventional EM, electromagnetics, with it because it was oversimplified. You know, the Heaviside Maxwell equations simplified the original quaternion equations, and he took the scalar component out. Okay?
So he's looking at, he's not actually producing longitudinal waves, but he's producing transverse waveform. Is that correct?
Yeah,
in his experiment?
Yeah, well, that's what I'm seeing on the scope here, is this sine squared term. And it has this built-in DC offset with it.
Yep. Okay.
So
well, we're talking in some certain similarities. We're at a higher frequency than what he's working on. We want to investigate HF down into the HF spectrum because equipment-wise, it wouldn't be as critical to make the VHF. The VHF equipment is tricky.
Right.
Very, very tricky. You sneeze on something and you change the frequency.
Right.
I'm being facetious here, but it's that critical. You space a fractal over a fraction of a millimeter, and you just screwed up your entire waveform. I can't tell you how many thousands of hours that we've spent perfecting the spacing of the fractals. That's critical to generate that. And the other thing is that I'm not too concerned about the break-in that we had because they stole one of our motors. I don't care how many motors that you steal. If you don't know how to create a field, you're shit out of luck.
Right.
I'll be quite honest with you. If you don't know how to generate the field, it ain't going to work. So in a way, to keep it secret, all of our stuff, we got trade secrets and it's copyright, it's proprietary. We have a patent pending, but not to the point that the government can walk in and shut us down. No one patents anything anymore of significance, from my understanding. After talking with Dr. Plutov some years ago, he said nobody does this anymore. And he says they don't want the government walking in and taking their stuff, like they did to Robert Goddard. I don't know if you know the real story, but Esther sued NASA and got $1 million. The only civilian to actually sue and win the case against NASA for stealing her husband's patented his patents on rocketry.
Well, Bearden says, forget about the patent, just go for the licensing.
Yes, yeah, and that's what we're after. You know, we're not. We're making progress. It's not enough progress that I'm happy with. I've had this medical setback, but I'm still moving forward. I'm still designing stuff. So damn the torpedoes, full speed.
Right. Yeah, Bearden said in his lectures, it's available right there on the internet. He says, well, you can do anti-gravity at 400 hertz. And John Hutchison was doing the RF waves, mixing RF waves, you know, where he levitated a 90-pound cannonball, which was very interesting. He got that.
Yeah, that's the guy up in Canada.
Right.
Hutchison, yeah. Right. He used the Tesla coils.
Fascinating work.
Yeah, it's interesting. But it can't replicate all the time. That's that's an issue. Is if you can't replicate, I don't know if it's positioning of his equipment, but he's not able to replicate on demand. It happens sometimes. It doesn't happen at least that's what I saw in the video.
Uh-huh.
So it's a shame that whatever he's discovered that he hasn't been able to perfect, unless he has, and he's gone secret about it, being able to lift the thing. We're all in the same neighborhood in a way of manipulating the fabric of space.
Right.
We're also looking into, and it's been in the back of my mind for some time, creating a longitudinal output waveform, scalar waves, but longitudinal, because that will give you about a 30% increase in effective power. So less power, more output of work energy. So I'm looking into that. That's kind of takes some finessing to do. Those are ideas that I'm still floating around. And I don't mind discussing that with everybody, because if you think you can solve the longitudinal issue of generating longitudinal waveforms in that manner, RF, hey, call me up.
Okay, brilliant
We have
work.
to modify all of our equipment.
Awesome. Okay. Well, Bill, thank you, sir. Let me lower your hand there. Let me go to Jared next, sir.
Hey, it's so awesome to see the amount of work that you've been putting in on this over the years. It's quite the treat to get to hear the most up-to-date work you've got on it. I got a couple of questions here. The first few should be just quick, wham, bam, bam, and then the last one might take a little more longer form answer from you. So first one, with Bruce German's airframe, you said that its clock matched the clocks on the ground. There was no offset in the clock.
That's correct. That's correct.
But his experience was of a much shorter time.
From a clock perspective, it was 47 minutes instead of 75. So he arrived earlier than normal, but that doesn't mean he time traveled.
Okay, but so his awareness, his perceptions matched the clock, which matched the ground clock.
That is correct. And that also matches Alcubierre's theory about no momentum for the crew, and that the time signature in the crew capsule would be identical to the observer on Earth.
Excellent. Next one.
No time dilation.
Awesome.
And that's significant, because if you did go to space and you were able to go faster than light, we calculated 55 million newtons to achieve that. Okay, it's not significant. We'll do it next week. It's a lot of energy, and I'm still trying to figure out how can we get there and do that. But if you're looking at the twin paradox of the twins go out, one comes back younger, the other one's an old man, you wouldn't have that with this. It means you could explore space into the deep reaches of space and come back and still be within the same time frame as we are here on Earth. And that would be a significant advantage in exploration of the solar system and beyond.
Awesome. Follow-up question. So if you said that his direction of travel, because he was traveling in a certain direction, that's why he didn't shoot off into space, why he shot, parallel to the ground.
Know that the mass of the Earth affects warp bubbles. He went in at 10,000, came out at 10,000. He followed the curvature of the Earth. And so this has also led me to try to develop a new navigation system using white dwarfs, red dwarfs, for navigation buoys in space. We got like 50,000 of these things within a couple of light years of, like about a couple hundred light years away from Earth. We have about 50,000 in the local star group. And if you were to fix on every one of those points, you could then adjust, because as you travel in space, trying to go in a straight line, you wouldn't deviate if you had a good navigation system to make the proper adjustments, since we know now that a warp bubble is affected by mass. It's not as what Alcubierre envisioned, go point A to B. There's a little bit more to this. And that's why we'd like to get to the neutral point 1 million miles away from Earth to the sun with our spacecraft and do some experiments there and have the effect of the Earth and being able to be testing that neutral point in space, one way or the other. We have a lot of unknowns here. Like, what happens if a particle comes in towards the motor? Does it penetrate in through the motor and destroy the spacecraft? I can't tell you that right now. One of the shots that I had on my PowerPoint was a shot of Star Wars, as they go into hyperspace, and you see the light coming across, the stars. I don't think you're going to see, if you go faster than light, you're going to have a milky screen, a windscreen in front of you. And you're going to need a navigation map, a computer generated HD screen in front of you, a heads up display that shows you where the hell you're going.
Well,
Because you're not going to be able to see anything.
yeah, all that light would blue shift too, right? Or yeah. So all that would shift up into the X and gamma range. So
Yeah, it's not what Star Trek, we've been so polluted with science fiction, is that the reality of the world is there is no noise in space. And notice that you hear in a lot of these other Star Wars things, there isn't any noise. And as far as when you go faster than light, you're not going to see anything. It's going to be this milky something. That's what I'm kind of envisioning, just because there is no focus. And they see the stars coming by and it's so beautiful. Oh, I'm cruising through space. Ain't going to happen that way, boys.
So if I could follow up with the next question, had you vacuum tested the device at all?
Yes, it has. Actually, there was a German lab who copied our design from our internet, our website, and actually tested it in a vacuum. Now, they copied our fractals. They obviously did a shit job because they didn't get the results that we did, but they did get results, but they considered it to be down into the noise level. But the bottom line of their paper that they published here, I think it was last year or a year and a half ago, the results was 0.005 newtons of measured force. And what they did was they had the torsion bar and they put the motor towards the torsion bar. And the motor and the torsion bar were in a vacuum. They turned the motor and the torsion bar didn't turn as fast. And as they put it towards, and that's the most significant part of this, even though that they did a crappy job and they only used 100 watts of power because they were too cheap to invest into a more significant, huge, well, I consider our linear power generator or amplifiers be really unique. They're custom, but they used a standard ham radio attainable linear of 100 watts. They both commercial off the shelf, but they got these, kind of results, but they didn't think it was significant, and so they concluded that our stuff was shit, that it didn't work.
That wasn't Martin Tamar's in Dresden University doing the test, was it?
I don't have that paper in front of me. Those guys pissed me off. So I read the paper and I deposited the results in the back, and it's in the, in the waste paper there.
Final question.
Yeah.
So for the fractal antennas, the fractennas that you got, have you looked into going into a 3-dimensional pattern form rather than keeping it in the 2-dimensional pattern?
Yes. That's kind of way off for us right now. One of my electrical engineer, he insists that I use triangles like cell phones and like cell phone arrays. And I'm leery about that because then I have to do all new research that's taken 10 plus years to do. I don't have that kind of time. I've got to work with what I know works, and I could be wrong on this, but I'm caught between a rock and a hard place on this thing. I'm trying to get results, and I'm trying to satisfy the doubting engineers that are out there of, well, you got to be over a meter of lift or else we don't believe what you did. And despite that, you can pull things through solid objects, influence objects on the other side of solid objects, we don't care. I don't know what the deal is here, but I think if I was at NASA and I accomplished this, they would be parading me around and I get the Nobel Prize in physics. However, since that ain't the case and we're working out of a garage, low overhead, I'll have you know, it seems like you can't do original technology or invention in a garage. Although all the major Fortune 500 companies started there, are we any different? We held to a different standard? Do I have to have a lab that has $1 trillion worth of hardware to be recognized? I don't know. So that's why we're out there. That's why we put the stuff on a website. That's why we videotape everything. We document everything. We produce the images, the graphics, and all that stuff. And so if people think we've been BSing them for the last 12 years, well, that's a whole process in itself to create that kind of fib. I mean, you know, what we do is real stuff, and it's replicatable. So I don't know. I guess seeing is believing, but I thought that the videotapes that we produced showed the movement and what we were able to accomplish. I don't know. You know, I'm still a little perplexed about the attitude, but this is a paradigm shift. I just have to understand is that you have to be able to educate people on what is going on, how it works, and the ins and outs without giving away all the real secrets of this thing, of how it really works. But to at least demonstrate to them that it does work in the future is here. Now, whether we're mature enough to utilize this, because I know of a ton of military applications which is not pleasant. I mean, and that's the thing that I think I talked about this last time I gave a presentation. I have severe reservations on the world in general and their attitude on warlike actions, but to deliver a bomb, you know, within a second, you couldn't defend yourself against any of this. The world would be in total chaos. That's why this stuff has to at least start in space. And then as people get more familiar with this, maybe we'll become more mature enough to accept this kind of technology to levitate cars, to fly aircraft across the ocean in a second or so, and not have to use oil, refined kerosene. I mean, think of a 747, that's 150,000 pounds of fuel that they burn. You eliminate that. And look what happened in 9/11 with 3 days of no aircraft in the sky. The actual heat energy budget went back to normal on the Earth instead of being delayed 13 hours. But it actually went back to 24 hours in, 24 hours out, in and out, no big deal. So is this kind of will affect climate in a good way? Yes, if we adapted more of this and we were allowed to advance technology to that state of using bigger and bigger craft to haul bigger masses to space and around the Earth, yes, it would definitely improve things in that capacity of our atmosphere. And I am an actual meteorologist and multidisciplinary scientist and engineer, but I teach meteorology and astronomy in colleges that I teach, and physical geography. I've cut down from 5 colleges to 3. I'm only teaching now about 50 semester hours a year, which is still over 2 positions of full-time faculty. But that's how I have to generate the money in order to fund this project. But with my latest medical fiasco that diverted money to pay bills. Oh, well, all in
Yeah.
the day's work, right?
Okay, well, so I think, let me see, I think Robert is next, right? Robert?
Yes, Tim, thank you very much.
Yes, sir.
David, very good presentation. I'm a big fan of Star Trek. And what's interesting, first of all, Robert Goddard's wife, Esther is the name?
Yes.
Okay. You said she helped gather some information, astronomical information.
But the actual data that he produced from his rocketry, and she assembled a 3-volume set.
Can you get that online?
It's been withdrawn from libraries. I got mine from a used
Really?
bookstore. Yeah, they're,
All right, so I might find on Biblio or Alibri.
yeah.
Okay, what's it called, the set?
It's a 3-volume set. It's in the cabinet. I don't have the name
Okay.
of the title. I have the books. I've read them. The title escapes me. During your presentation, I'll go over and take a look, and I'll write it down, and I'll let you know at the end of your presentation.
I don't have a presentation.
Oh, you were next. When he said you were next, I thought you were giving a presentation.
No, no.
Okay, gotcha.
Is it on your website?
Those books?
Yeah.
No,
No, I mean the title.
no,
Okay.
of the books. But you could, if you look up the Robert Goddard by Esther Goddard, she would pop up. I'm positive of that.
Okay. What kind of data is it again?
Oh, it's photographic. She took all the photographs of the rocket launches, and she wrote all of the lab work that he had done. They're real. The entire book set is about this wide.
Okay.
3-volume set.
Yeah.
It'll cost you probably close to $300 to get this.
I think it was interesting. You mentioned there's no time dilation. Now, that's one of my researches that I don't think there is any time dilation. I don't think there's any length contraction or I forget what the other, I think it's our perception of nature that gives the appearance of this. And it's interesting you started researching thunderstorms because nature, I believe, holds more secrets than realized. Victor Schauberg discovered many secrets of nature. He had some very unconventional research and that. And I like to share with you on that if you want to. But I'd like to get your website down if possible.
It's named QED. QED dash NE.
Hyphen?
Yes.
Okay. NE is
Nebraska.
N is in Nancy?
Yeah. Nancy
Okay.
Echo.
All right. Very good. .com?
.com. Correct.
All right. Thank you
It's
very
got all
much.
of it's got all of our papers, videos, images of our work. Not as extensive as I did here for your presentation. One of my guys is a little touchy about divulging too much stuff, but I figured for you guys, hey, why not?
Well, yeah,
Roll on the business together.
And
Okay.
David,
Thank you very much, David.
You're welcome.
Thank you, Robert. David, I would say, if you feel uncomfortable or if your team feels uncomfortable about divulging anything, definitely don't share that.
No. Look, I'm the guy who makes the decisions, and I've only given you what I've determined that I will give you. That's all. Which I think was quite a lot. But
oh yeah,
you don't have all the real intricate stuff that would make me very concerned. At this point, everything I presented is out there.
Yeah, that's perfect. Yeah, I don't want to steal anyone's secret sauce,
No,
so to
no,
speak. You
no.
know, that's not what our conference
Wasn't
is
asking
about.
for that myself.
Yeah. Okay.
Other
Well,
than the Germans stealing our stuff,
Yeah.
but actually they did us a favor by putting it in a vacuum. We had some people that kept insisting that we put the whole thing into a vacuum, and I said, "Look, I don't have $10,000 to build a vacuum chamber and all that, and that's just like conservative, and to go down to how many pascals, you know? I said I'm not doing this, and these guys did it, so I said, okay, fine. You know, somebody paid them 30 grand to replicate our stuff. And
how would you say your work is an extension to Townsend Brown's research, or a totally different area?
Looking at electric wind from Brown's experiments to what we do, we're not like an ion lifter. You know, we're not affecting, quote, the atmosphere. And the fact that the Germans did us a favor by putting it in a vacuum and got the effects that we got in a terrestrial environment was satisfaction in that respect. So are we generating an ionized field inside? It doesn't appear to.
So you're truly a field propulsion type of research, I would think.
We're literally compressing the fabric of space, which is really fascinating from the aspect of, from a relativity point of view. It makes no difference where you're at. Mass or energy can affect the fabric of space. And that was another conclusion that we came to. I mean, it's on a micro or miniature aspect, but when you ramp this thing up, this has some powerful implications.
I'm interested in reading about the details on your research and thunderstorms, what you discovered, the past history of airplanes make it to the destination minutes or hours before they're scheduled to arrive.
That particular paper was removed from the website. We can probably mount it back up again because it was like old hat. You know what I mean? It's just the old story. And
I've never heard of it.
Well, like I said, I'll talk to the guys, the one guy that administrates our website. And he
Don't make a big project out of it, though.
Yeah.
Well, I'll look into it. I mean, the paper's been written, you know, and it's we had it out there before. It's just that there's an evolution to the thought process that occurred from Bruce Kernan's paper that I wrote to today. I don't want to say it's 180 degrees out, but what I'm saying is what we learned is so more detailed in understanding how this process really works.
I'm interested to see your website, what you said about thunderstorms that could be causing this phenomenon.
We talk a little bit about that in the major paper that we presented to the AIAA.
Yeah.
Okay.
Well,
Thank you. Thank you very much.
Robert, thank you, sir. Let me go. I'm trying to move things along a little bit. We've got probably about 10 minutes left, and then I think we're going to go to Mark. So let me go to Michael Boyd next, sir.
Hey, David. So I'm curious. You mentioned about you don't think that you can go faster than the speed of light, and would you consider quantum tunneling an example of superliminal information exchange?
Well, I've looked at that as a possibility. I mean, the fact is that nature's telling us that it can be done. I mean, it does it.
Yeah, well, your cell phone, the touch part of your cell phone, that's quantum tunneling. That's actually applying quantum tunneling. It's well accepted that it's possible to go across a barrier what appears to be instantaneous, but if you think about it, It's
like entangled particles.
going over a distance, however small it is,
Right.
faster than light to do that.
Yeah.
So
And what I'm saying,
obviously there's no signal loss because, like you were describing, it's not heating up. It's not.
That's correct.
It's
right.
It's just a property of nature. Essentially, it's natural.
Yeah, and I think the upper limit is point of singularity for energy level, that you can't go faster than that point of singularity.
So, Tim, would it be okay if I share the video image of the Tic Tac?
Actually not at the moment, because we're kind of pushing up against our schedule, and I want to get Mark on at 5. Now we do have an open discussion coming up today later, and actually during that, Phil Bouchard wanted to present something as well. So we can.
Okay, so that's fine. The other question I had, David, is your fractal antenna array.
Mhm.
Have you considered stacking them?
Kind of like a supercharger, like a turbocharge.
So
Yes, I have.
What you want to do is create what's called a surface plasma, and what it is it's a particle wave, but it's in the horizontal direction. So essentially, it would create your what do you call it? Your propulsion, your linear propulsion would come from this surface plasma. It creates what's called a torsion field. Between the different layers, you create a torsion field. The other thing that's important to consider is a kind of like a dielectric material that your antennas are embedded in that. And there are certain dielectric materials that have certain properties that would similar to, you're basically trying to tune it, right?
Yeah.
Recording in progress.
So you know, I suggest you consider that, and I appreciate your answering my questions. And that's it. Thank you.
You're welcome.
Okay. So let me go to Jeremy Rees next. We have someone else who is recording, but that's totally cool. And actually, somebody asked me about that in chat earlier. I've been recording for, let me see, close to 6 hours now. So, and then I think Jeremy is live streaming also. But speaking of Jeremy, let me go to Jeremy next. All right, Jeremy, you're live streaming, right?
Yeah, I am live streaming. So I have a couple questions. Yeah, we're live streaming on YouTube. I think we got 83 people right now watching live. The questions, I got a couple questions from the live audience. Join the Technicians wanted me to ask you about the enclosed box pendulum test that you did.
Yeah.
Can you comment on that enclosed box pendulum test?
I thought there was additional comment about that. Yeah. So the box was made of plywood and glass, and the pendulum, well, the torsion bar was suspended with monochrome fishing line. And then a neutral point was attained. We used a non-conductive mylar mirror on the end of one of the non-ferrous material. It was able to be moved between that and the ferrous material. And then we used a pen laser of a basically insignificant amount of power that was reflected off the mirror. And when the experiment was neutral, in other words, no movement whatsoever, we had dampening pads underneath the box. And so when there was no movement detected, and we turned on the system and used the laser to measure the movement of the torsion bar. So that was 1.5 pounds of material in the one experiment that we did, and 3.5 pounds of the ferrous material being moved on monochrome pitching horn. And so what it proved to us was that we were able to effectively, through the compression of the fabric of space, was to move a freewheeling object within a solid case. So it went through solid material and influenced something on the other side. And we did it up to 140 centimeters away. This really eliminates the speculation that there was charged particles, that there was charged air, that there was an attraction of some kind. We went to large extremes to show that the reaction went out to that distance at 25 watts of power. I mean, that's pretty significant. And 100 watts of power. And doing the actual curvature graphs of our, that we were actually recorded, and the swing rates and the algorithms that we made to do pre-prediction on power versus the engine size and variability of the motor, the main structure. So we did an awful lot of that took close to a year of testing that we did alone.
And then the next question I had was about the exponential fall off in the thrust after turning the device off. And did you ever measure any electrostatic fields after the operation and test for that sort of thing?
We have a tri-field meter that actually is near the cage, which would measure any of that. And we did not get any static measurements of electricity. We have other meters that would measure that as well. The magnetic field was gone, but yet we still had an energy level. And again, I haven't had time to research that particular facet of this engine, but my initial speculation was that it could be attributed to the rebounding, and that's what I feel it is a rebounding of the compression of the fabric space in the back of the motor kept pushing it. Because once the power is off, there really isn't any kind of compression, but in the back of the motor, there's this gradual relaxation, and it could be as a result of that. Still has to be researched. It doesn't match Alcubierre's theory, but then again, I believe that his theory was a device that compressed the front and expanded the back. We're not doing that. We're only doing one in the front.
Thank you. And then the third question, I don't know if you can answer it, but it says he wants you to talk about the driving signal that you use. Anything you can comment about that, or what you're driving it with power wise and wave?
Well, these are custom linear amplifiers. They're in-house design, and we don't really talk a lot about the structure of this stuff, but what I can tell you,
waveform.
The waveform, no, we don't talk about that. We don't talk about the frequency, nor do we talk about the waveform. I'm sorry, but there's something.
No, I understand why, and that's why I said it. If you can answer the question. No.
Yeah. We do generate right at this point 2,800 watts with the current setup. We have a capacity to generate a little over 5,000 watts of power when all of the linears are online and combined together.
Yeah. Well, and again, don't talk about anything that you don't feel comfortable about. I think
you're
that's
right.
more than fair. Yeah.
Yeah, sure.
Yeah. Okay. Well, Jeremy, was that just about everything that you had, or?
I might have had more, but they might have gotten lost in the,
okay.
in the mix.
I have about 2 minutes until the top of the hour.
I'll see if I can get to their questions, but otherwise.
Okay, well, so let me do this. We're at the top of the hour, so let me put this back on gallery view. And again, everyone, please give a giant applause to Mr. David Brace. Sir, thank you so much for sharing, and thank you for doing the Q&A with us as well. That's remarkable technology, and the depth and scope of what you presented today is just amazing. Amazing. You know, this is it's based very much on your last presentation, you know, as we talked about earlier in the week. But again, you've taken this so much farther, and it's just amazing work. So thank you yet again.
You bet.
Okay, so what I would like to do now is go to Mark Sokol. Mark,